In a chemical reaction road trip, we can use curved arrows to show which bonds break in the reactants and which bonds form in the products. When we use curved arrows to show how a reaction occurs, start at the base or electron pair donor or nucleophile and end at the acid or electron pair acceptor or electrophile. So stop the video and look how water, which behaves like a base, reacts with hydrochloric acid. Note that an OH bond forms and the HCl bond breaks. So let's practice. CH3COOH, acetic acid, reacts with the hydroxide ion, OH- to form the acetate ion, CH3COO- and water. So stop the video and identify which curved arrow shows this reaction, and then draw the products of this reaction based on your curved arrows. So the answer is A. The lone pair on the OH- reacts with the acidic H and acetic acid to form an HO bond to form water. Then the OH bond in acetic acid breaks to form the acetate ion. Note the other two possibilities do not give the correct products. In this practice problem, you're given the structures of the reactants and products, so stop the video and use curved arrows to show which bonds break and which bonds form. So here's the answer. This is a reaction we'll look at later this semester. So this compound is the acid. This one is the base. So stop the video and use curved arrows to show how the acid reacts with the base and draw the structure of the products. So here's the answer. Here's an application of acids, bases, and pKa. Let's say you have a mixture of benzoic acid, the acid, and phenol, which is a base. How would you separate the benzoic acid from the phenol? First, note that phenol not only is a base, but is an acid. Take a look at the pKa, which equals 10. Benzoic acid is a stronger acid than phenol, so you want to use a base which reacts with benzoic acid, but not the phenol. The pKa table helps you identify the appropriate base. So baking soda reacts with benzoic acid, but not the phenol. This allows you to separate the benzoic acid from the phenol. After the benzoic acid reacts with baking soda, the benzoate ion forms. How would you convert the benzoate ion back to benzoic acid? Stop the video and figure that out. The answer is benzoate ion is a base, so it'll react with the appropriate acid. Again, take a look at the pKa table. You can also use the pKa table to predict the charge of an acid or base at a specific pH. This is important in biology because charge often determines solubility. You can also use charge to separate one substance from another in a mixture. For example, aspirin is an acid. It has a pKa of 3. Note the charge on aspirin is 0, but the conjugate base of aspirin has a charge of -1. In the acidic pH 2 conditions of your stomach, aspirin has a charge of 0, but in the blood, which has a pH 7.4, aspirin has a charge of -1. The amino acid glycine has 2 acidic protons. The proton, which has a pKa of 2.3, is a stronger acid. So if you did an acid-base titration of glycine using sodium hydroxide, the more acidic proton gets removed first. As more base is added, then the other proton gets removed. Note the charges. So at pH 2, glycine has a charge of +1, and at pH 7.4, glycine has a charge of 0. An acid-base titration curve helps us figure out how charge is related to pH. We need to know the pKa of the acid. When you start titrating an acid with a base, initially there's more acid than base. Continue the titration to the halfway point, which is an equal concentration of acid and conjugate base. At the halfway point, the pH equals the pKa. Continue adding base, and then there's going to be more base than acid. So in the aspirin example, aspirin has a pKa of 3. So when aspirin is in the stomach, which has a pH of 2, we'll be around here. That means there's more acid than base, and the charge in aspirin equals 0. At a pH of 3, which is the halfway point, half of the aspirin will have a charge of 0, and the other half of aspirin has a charge of -1. At pH 7.4, which is past the halfway point, aspirin will have a charge of -1. We've looked at how acids react with bases. And we also looked at how we can use curved arrows to show how bonds break and form when an acid reacts with a base. This table tells us some other terms for acids and bases. and some of the structural features we can use to identify an acid or base in a chemical reaction. So take a look at structures A through E, stop the video and identify each compound as an acid or a base. So here are the answers. Here are some reactions we'll look at later on in first semester organic chemistry.